And let's start with a summary of what we'll be covering in this webinar today. So we'll start with a brief introduction to the inverse design method and discuss the problem statement. Then we'll be looking at how the mean line design of a mixed flow pump stage can be performed. Then we'll see how the impeller and diffuser can be designed using the 3D inverse design approach. And after which we'll be evaluating the hydrodynamic performance of the baseline pump based on a CFD analysis. Then we'll be looking at a parametric study on the baseline impeller to understand how different design parameters impact its efficiency, suction performance, and blade integrity, and then use its study to redesign the impeller using the best combination of these conflicting parameters. Then we'll see how the efficiency of the redesigned impeller can be further enhanced while still ensuring a good suction performance and mechanical integrity through the use of automatic optimization with inverse design. And then finally, we'll wrap up with some concluding remarks. So let's start with an introduction to the idea behind the inverse design approach, which we use throughout this webinar. And as you can see here in this workflow, these are the inputs that are used by the inverse design method to give us the final blade design. So apart from some basic parameters, these blade loading inputs are really flow related. And so once you have a good understanding of your specific flow issue, whether it's profile loss, leakage, or cavitation that you're dealing with, it's possible to come up with guidelines on the optimum blade loading to tackle each of these issues. And actually this know-how has generality, which makes it suitable for all your pump applications. So then all you need is to rely on your knowledge of flow physics, and this method works for you regardless of your pump size or speed. So this makes the entire process very intuitive and removes any empiricism that's commonly seen with traditional design methods. So let's look at the design of pumps in a bit more detail. So across the specific speed range, pumps are subject to various flow phenomena and loss mechanisms that are dominant in the particular range. For example, as you can see in this specific speed chart, this leakage and secondary flow effects are more dominant in the lower ranges, whereas profile and corner separation in diffusers takes priority in the higher ranges. Also, a phenomenon such as cavitation can affect pumps over the entire specific speed range, and then this is something that must be dealt with on a case basis. And in fact, with inverse design, it's possible to come up with a set of optimal design guidelines based on these fluid dynamic considerations of reducing the dominant losses. And this is actually what we aim to explore through this webinar. However, when it comes to the high specific speed mixed flow pumps, there is usually a trade-off between the hydrodynamic, suction, and the structural aspects of the impeller. And this brings us to our problem statement. So the design of high specific pumps is challenging because while it's common practice to use four-loaded impeller blades for efficiency purposes, but it also aggravates cavitation levels in the impeller. And although cavitation can be addressed with modifications like leading edge sweep, they take a heavy toll on the blade stress. So clearly this is a complex multidisciplinary problem, and this is why conventional methods always involve like a large number of CFD and FEA runs in order to ensure that the appropriate trade-off is achieved, which consumes a lot of computational time and resources, of course. So the question then is whether it's possible to come up with an easy systematic study to separately evaluate the effect of these different design parameters on the various performance aspects of the pump. And also, is it possible to develop a rapid optimization methodology focused at suppressing the dominant losses, but without adversely impacting the cavitation and stresses in your impeller? And this is what we aim to explore through this webinar.